Hey guys, so Dilly and I are here discussing one of the products that we're going to be releasing, starting with the grip market, and this is going to be for the S2000. Basically, this began because Dilly has an S2000, and a friend of ours, Justin, happened to be breaking rear components on his S2000 multiple times. So then when we got to look into the market, Dylan knows it much better than I do, but I began to learn it by seeing the method of adjustment that everyone was using on these cars was not a good design. And then we found that there really was no good design regarding this chassis at all. The main design component that all of the arms were using was a Heim joint on the end. And depending on the type of suspension that you're running, in the case of an S2000 with a rear upper control arm, it's not allowable, especially with the double adjuster method, where the knuckle wants to rotate and the only thing preventing it from rotating is the Heim joint on the end of the arm with a double adjuster. So it's like exaggerated on how bad
you're
that is.
always working to loosen one of the jam nuts.
So it really began with looking at what was on the market and realizing there was a huge hole in making high-end performance parts for these cars because they were overrun by China parts, basically, which is a Honda thing.
Yes.
But then an S2000 is a top-tier Honda car with good design geometry. It's a double wishbone suspension system. The rear is quite similar to a Corvette. It's got an upper control arm, a lower A arm, and a toe arm on the front side of the knuckle. This is a rear knuckle. This is a front knuckle. And then of course, Dylan has a bunch of guys that he's friends with within this market, which would be the most important one, which is Andy from ASM.
Yes. What was the first product that we actually, was it the rear uppers or was it the knuckles that we started with?
We were doing two things at the same time. We were looking at how can we make an angle kit from the front knuckle geometry without replacing the knuckle. The reason why we didn't want to replace the knuckle is because it's a press-in bearing, and we didn't want to go to like a bolt-on hub because that's going to be requiring to use a different chassis bearing, like a 350Z. And whenever you do that, it's likely that you won't be able to use the rotor or the caliper or the center bore of the S2000, so we wanted to maintain those things. So looking at the knuckle, you kind of just stare at it for a couple of hours. And from that, we came up with a bracket for an angle kit that picks up on the knuckle, gives us a lower mount, double shear for the tie rod mount. But then from that, it evolved into probably the best design for a grip setup, which is a bump steer adjustable double shear design in the factory location. Normally on an S2000, if you have enough bump steer correction on this outer tie rod, it's basically an extra long stud.
Yeah. And then the roll center as well, right?
Yeah, if drivers are adding roll center, which is a spacer here to lower the ball joint, they're lowering their tie rod mount, which puts an excessive amount of force on this tie rod pickup, and this piece actually ends up breaking off with minor contacts or just overloading the car with big tires. And in racing, guys are putting pretty big tires, 10, 11-inch wide wheels.
Yeah, up to like a 295 now in some cases.
285, 295, like our compound race tire, and they're putting a ton of force through these knuckles where they're actually breaking off some mounts. Like on the front and rear knuckles, what's breaking on these just from grip driving?
Yeah, so that would be the point of the rear knuckle. Was Andy at ASM had kind of approached us. We said, hey, we're looking to make some S2000 stuff. What's the top of the list? What do we need to make? Problem
solving.
Yeah. So he said, listen, rear knuckles. He's like, we're snapping the ball joints off the rear knuckles. He said, in an endurance race, he's like, sometimes we'll go through two knuckles. He's like, obviously, to go in and swap a spindle out, that's a lot of time. That's your race essentially. So what we did was come up with a plate that's welded in. We TIG weld this, preheat the cast, cool it down, and Andy has tested that over the course of the last year now. We've went from having a couple failures or a failure every couple events to no more broken spindles. So working with Andy is really good because he won't run anything that they don't test and they're not happy with.
Yeah, exactly.
So he says, I'm gonna put it on the car, I'm gonna go and beat it. If it works, that's good, we got a product we can sell. So now ASM exclusively offers these knuckles. It's an OEM Honda knuckle. They get sent up to us, we weld the plate in, we paint them up, ball joints go back in, they go down to to Andy. So you can buy these from AS Motorsports. But that led on to basically what else can we do here? We also looked at the front knuckles, as Josiah said. Increasing the roll center will put more leverage on the casting right down here. That can tend to snap off.
The lower mount where these two bolts go into, they actually snap off as well,
Yeah.
given the forces applied by road racing and wheel-to-wheel road racing specifically. Ruins wheels and wrecks suspension because you're trying to pass, you're trying to make passes, you're diving in. Contact is inevitable, and it's usually at a much higher speed than drifting. And the hit-to-hit is usually a lot more aggressive because you're both fighting for a line, and drifting, you're not fighting for the line. You're not trying to hit them. Like,
No.
usually in drifting, it's more of a graze or more of a bump. In racing, it's like, you've committed, I've committed, and it's a crash.
It was completely
It's a full-blown
unintentional,
crash.
but it is going to happen, yeah.
So that's where we've gotten to with the thought process on designing these. But let's go over what the products actually are. So we've made a front knuckle roll center correction, bump steer adjustable knuckle brace. So this piece actually ties in with two holes that were just miraculously there.
They exist in the knuckle. They were literally a tap drill size for M12.
Yeah.
So we went over, we fitted up to a car. We looked at everything. We said, let's make sure there's no interference. Initially, we were going to go to the brake ears. However, with some big brake kits, the caliper adapter is going to mount to the backside of the brake ear to keep the offset, which basically made this design to tie into the knuckle very difficult to do. We looked at those holes, we tested it out. It works really well, actually. So
this material is a high-strength alloy steel that measures between 190 and 210 KSI. For reference, mild steel is around 45 to 50, and chromoly is around 85 to 90. So it's roughly 4 times stronger than mild steel, 2 times stronger than chromoly, plus a little bit of tax there. And that is why we chose to go with this material. It does look like, that's a simple plate structure design, but also simplicity is key when it comes to reliability, adjustability. So that is the front knuckle design for reinforcing the knuckle on all of the critical points and giving us all the adjustment benefits from a bump steer kit and a roll center kit. The next product that is on the table in this line is a rear upper. The problem with what was on the market was, like I said, all the adjustments are made at the end of the arm, whether it's an offset ball joint, which is common to do to the stock rear.
Yeah, and that's what I had ran on my car previously, just because, like Josiah said, I'm not a fan of the double adjustment nuts. They're always coming loose. There's a difference when you have something you can bolt check and it's maybe you just got to snug it up. But as soon as the tension is released on the Heim joint or on the double adjuster on the end of that knuckle, it's going to bend right away, basically. So it's depending on having that torque hold everything together, and as soon as it comes loose, it's basically just waiting to snap.
Yeah, so the concept on this design was all about simplicity. We have a single plate that holds both mounting points for the smooth adjusters. These smooth adjusters are what allows you to adjust the control arm. You guys have seen these lots before, but not in the race world. These things are not seen in the race world. And then we have a factory ball joint that is machined to the upper control arm thickness, and then you press in a high quality ball joint, then you'll never have a problem again. This arm is like the same weight as a stock control arm, which is also a pretty high strength alloy steel. The stock arms, there's not issues with strength regarding the stock arms, but they're non-adjustable and they have bushings. So we want to get rid of the bushings and we want to make it adjustable for getting the fine-tuned camber spec. These control arms are designed specifically for road racing and getting that optimal camber, which is -2 to 3 degrees typically, whereas in drifting you would be extending these quite a bit to get the opposite of that, 0 or +1-ish. They can utilize and be used for
I was going to
both.
say, however, Justin is running those on his car.
Exactly.
He gets just over, I think, like half, basically a degree of positive, and they're working really well for that too.
Yeah, so Justin actually had an issue where he thought the knuckle was failing here at the lower control arm ball joint. And this knuckle's a bit weird. It sits in the car
rotated a bit.
Like this. It actually sits in the car on a very strange orientation. It sits in the car more like that. This is the lower control arm ball joint, and this was snapping off on Justin's car. And he was basically blaming the knuckle every time. But what was actually happening was the upper control arm adjustment, which is connected on there like this. On his car, it had a Chinese heim joint on the end, and that heim joint was failing. It was breaking. When that heim joint breaks, the knuckle is allowed to rotate, and that rotation actually twists this ball joint to its maximum and then snaps it off. And then he thought this is what was failing, but actually it was definitely the upper letting go.
First, yeah.
Rotating the entire assembly, snapping the ball joint off, and then his wheel disappears. The third product is the knuckle brace that's welded onto the rear knuckle. Again, same material that we use for the front and the rear uppers, welded on, TIG welded, preheated, all of that good stuff. We press the ball joint out, then the ball joint gets pressed back in after it's painted. This is a simple weld-on product that you would need to send your knuckles to us to have done, but Andy does buy these at ASM and he does sell them from his website. And then Dilly, you cover the last arm there.
So these would be the front upper control arms here. Very similar method to the rear uppers. It's simple. We're using the smooth adjusters, which we've proven out over the last couple of years to be just a very robust. It's simple, it works. I mean, these have been on my car, the uppers, for a better part of a year. We've got guys like Andy testing them. We've got guys like Nick at 851 Motorsports testing them. Alex is testing like some of our drift stuff as well. So these have been on cars. We've been testing them. We've been putting them through their paces. Everything that's come back has been very positive strength-wise. There's no failures. So yeah, basically this design, same material. We're using the OEM ball joints or OE style ball joints. The nice part is Honda used the same ball joint front and rear.
Yeah.
So if you need to find a pair, you're just ordering. It's the same part number, it's the same ball joint, same bore. So we machine all these in-house, do our little flat here. We do our bore to a specific size, so when we press them in, it's a nice, good press fit. These OE ball joints actually have a snap ring with them as well, which the Honda ones don't. They're just a press right in. So, I mean, a couple times of replacing ball joints, that bore is going to start to get a little oversized. Without a snap ring in it, you're basically just kind of hoping that it stays
it won't
in.
come off the car, but it will dislodge itself from the press fit if you have worn out. It happens on Corvettes all the time. It's the same design.
So yeah, I mean, basically these arms are working really well. I think the only limitation for these are if you will be
Nice color.
So yeah, another thing about what we wanted to achieve with these is making something that was essentially competitive in the market, right? We don't want to make these and then they're double, they're triple the price, because we want them to be available as just basically a straight swap. You want to get rid of stuff that's overseas that you're having issues with staying tight. These are right in the ballpark of anything you're going to find. These are going to be right into the price range of what is probably on somebody's car already, and it's going to be much stronger. I mean, essentially all of this stuff, minus the ball joint, we produce ourselves. Everything is here.
This is essentially the kit you would need to buy for your S2000 if you want to race it. Everything that you see on the
you don't want to snap knuckles. You want the adjustability for camber. And I mean, these will also adjust some caster as well with the smooth adjuster design to an extent. You got your roll center correction, you got your bump steer correction, and minus a toe arm, which I am currently working on making a stud, getting that out for testing. That's everything that you're going to want to, slap on an older chassis, replace and refresh some parts, go out to the track and have complete confidence in your suspension.
Yeah, so that's a new product that we're releasing into the grip racing market, road racing, grip racing, whatever you want to call it, time attack. And these are going to be coming out for the S2K.